Sir, I will start discussion. If any questions, please type in chat. Today we are going to take an introduction session about Azure Data Factory. So simply in shortcuts, you can call it as ADF. So simply what is ADF is a cloud-based ETL tool. The two of Microsoft in Azure Cloud Platform. So you generally call it as ETL, but in fact our working style is ELT. So what is full form of ETL? Extract, transform, and loading. That means connecting with different data sources, performing data transformations, and finally load into target data warehouse systems. This is what basic nature of the ETL. But if you talk about ELT, just reverse process. Extract is common step. First load into target and then transform the data. Okay. So simply, even though ETL kind of mechanism is existed, why we should use ELT? The simple basic reason, this is good for small data. But very bad for big volumes of data. If a single table has more than a terabyte or multi-terabytes of data, if you work in the style of ETL, the process will be very delayed. Even 1 terabyte data processing may take hours of time, multi-hours of time. Even some processes may take even days of time. That's why for the big volumes of data, the process required is ELT, extract, load, and then transform. This is suitable for big volumes of data. So whenever you are calling big volumes of data, generally the big volumes of data in terabytes or petabytes, like this. As you know, data volumes, kilobytes, 1024 kilobytes is GB, gigabytes, sorry, MB. 1024 MB is gigabyte. Again, multiples of 1024, that is terabyte. Nowadays, organizations have already reached petabytes and more than petabytes. Even some organizations reached exabytes and zettabytes also, next to the petabyte level. So here, as a data engineer, your challenge is first point number one, how to store the data, and then how to process the data with a fixed speed, with high speed. So to support this, normal existed ETL tools won't support that much of volumes. That's why you need cloud solutions that do in a parallelism processing style, parallel process style. That too with in-memory computing kind of processing styles. That is what is simply ADF. About ADF fully we will discuss after a few minutes. So first, ADF is just one of the Azure Data Engineer product. So first of all, what are all the different Azure Data Engineer products are available? What is the purpose of each product and how ADF is going to interact with them? First, you should understand that one. Please go. So first, we are going to take some list of the Azure Data Engineer products. These products are about Azure SQL. And second one is Azure Data Lake. And then Azure Data Factory. Before that, Azure Synapse Analytics. And now your product is Azure Data Factory. Even though you are an ADF engineer, but you will have to interact with other products. So very regularly we will be interacting with other products. Suppose for my ETL process, for my ETL pipeline, data source is Azure SQL, target might be data lake or Synapse. So one is source, another one is target. So as a ADF developer, I need to interact with other products. Still you have other products like Azure Databricks, and Azure Cosmos DB, Azure Streaming, and Azure Keyword. So these are the regular products in the Azure Data Engineer family, product family. At least for today, we try to understand the first 4 products. Okay. So I'm going to talk about Azure SQL now. Azure SQL is a cloud RDBMS database of Microsoft in Azure. That's why it is called as Azure SQL. So, but this is used for only for the OLTP operations. What is OLTP? Online transaction processing. So the OLTP systems captures end user transactions. End user transactions means whatever the operation, whatever the transaction you have performed, that has to be recorded in some database. Okay. Suppose if you take example of a banking, you are withdrawing money, depositing money, transferring money from one account to other account. All these things are transactions. But these transactions should be saved. That means should be recorded into OLTP systems. Nowadays, most of OLTP systems are in RDBMS. Of course, the latest trend is there for the OLTP, that is NoSQL databases. Nowadays, for OLTP, there are 2 types of systems. One is regular RDBMS. Second one is NoSQL. NoSQL means not only SQL. Actually, the Cosmos DB comes under NoSQL database. So what exactly the importance of NoSQL? In the Cosmos DB discussion, we will do that. Okay. See, simply Azure SQL, you can comment it as that is a database, category is RDBMS. But in case of RDBMS, you have regular databases. A lot of popular databases are there, like Oracle, DB2, SQL Server. This is also my SQL Server is Microsoft product. And I have PostgreSQL. Even MySQL. In this way, many databases are there. Then what is the difference between these databases and this Azure SQL? Both comes under RDBMS category only. But what is the difference between them? Basically, these databases are on-premise databases. On-premise databases means you need to set up your own hardware infrastructure, and on top of this operating that hardware, that means hardware server, you need to do your operating system installations, and then you need to purchase the license of database, then installation of the database server, and then designing your database objects. So finally, to maintain this one, you need a hardware team, operating system team, networking team, security team. Lot other teams are required for, apart from database administrators. So total maintenance is by you. If any risk happened, the risk has to be paid by you. So these are on-premise databases. But this Azure SQL is simply, that is also comes under RDBMS only, but this is cloud. This is on the cloud. So you need not to maintain any infrastructure for that. No need to purchase any licenses for that. That too, nowadays for a database, if you purchase a license, again, the license validity is very limited period, maybe 2 years or 3 years, depends on the vendor. After completion of that, you have to renew that. Got it. So if it is Azure SQL, everything is on the cloud. Only simply you create your Azure SQL instance, and your applications can start writing data into that and can read data from that and can perform any CRUD operations. CRUD operations in the sense inserting data, deleting data, updating data, retrieving data, anything. But Azure SQL purpose is only for OLTP, not for the data warehouse. Only for OLTP. Understand? You take any system, there is a problem with OLTP systems. The problem with OLTP systems is very limited capacity. So limited capacity in terms of storage and in terms of processing speed also. That means less storage capacity, less processing speed. So that's why always in OLTP systems, they are compromising and then they maintain only limited data. That means the recent data into OLTP systems. That too, one single organization will use multiple OLTP systems. On each OLTP system, different databases will be there. A small example for this, I go with the paint. Just check this. Treat each box as a OLTP system. All my OLTPs are in RDBMS. That too, I am maintaining only 2 years recent data. Why only 2 years recent data is? I have a problem. The problem is this one. I have limited capacity. If your organization has history of 30 years or 40 years, all the 40 years data you cannot keep into OLTP. Okay, because of less storage and less process speed. That's why you are compromising maintaining limited data. That means that to recent data. That is the reason if you go for a bank, if you ask for a 6 months bank statement or 1 month bank, 1 year bank statement, immediately they could able to give. Suppose for the same ICICI bank, if you are the customer since 2000, if you ask for these 22 years of a bank statement, immediately they cannot deliver you. Because your 22 years history of your account, that is not available in their OLTP system. That is available in some historical database, which can capture entire history. That is called data warehouse. But how much of data that they keep into their OLTP system, that depends on their transactional frequency. So per minute, how many transactions are happening, or per second, how many transactions are happening, depends on that, depends on the capacity of the system they maintain. They decide how much of recency, that means the recent data they need to maintain. Maybe 2 years, or maybe 6 months, or maybe 3 years. Okay. So on that way, the strategy will be different. And I'm sorry. So think that one typical organization maintains multiples of OLTP systems. Maybe for one OLTP system, Oracle is the database. For some other applications, there might be SQL Server is the database. And still there is a sales application, for example, for some other different applications, they have MySQL. And they have some social media network site. So for that, they might be using some MongoDB kind of MySQL systems. But MongoDB not comes under RDBMS database. That is NoSQL category. In this way, in the phase of OLTP, 2 varieties of systems you can find. One is RDBMS category. Second one is, the latest one is NoSQL. But remember, NoSQL is not a replacement to the RDBMS. RDBMS has its own role. NoSQL has its own role. Some operations cannot be done by RDBMS databases. Such kind of things can be done by NoSQL databases. But the thing is, they are maintaining recent data into OLTP. But where to store entire historical data? Suppose your organization has 30 years or 35 years history. On average, per year, they are generating 2 terabyte of data. Suppose 35 years means 35 into 2, 70 terabyte of data. But I cannot go 70, I cannot keep 70 terabyte of data into my OLTP. That's why I need to maintain one powerful system for the historical data store. That is simply called as data warehouse. Nowadays, we are talking about not data warehouse, we are talking about a modern data warehouse. What exactly the modern data warehouse? After a few concepts, you will be understanding. Okay, I'm going to bring a big system, which is called as a data warehouse. Of course, in the beginning, most of data warehouse systems are in, again, RDBMS, Relational Database Management Systems. But Oracle, SQL Server, MySQL kind of RDBMS systems cannot store that much of volume. That's why for the data warehouse, there are specialized databases, special databases, which are used only for the data warehouse, not for OLTP. Those databases are Teradata, Netezza, and Vertica. Such kind of systems are available. So when compared with Oracle kind of systems, very high storage capacity and very high processing speed with parallelism. So 3 benefits are there with these databases. One is high storage. So you can store multi terabytes of data into this. And speed is high. That means you can say high speed when compared with the traditional systems. High speed processing. And also it supports parallel process. What is the meaning of parallel process, especially for the new guys? I'm going to explain this in a short line. A small example, sir. A general task. You can break one stick in 1 minute. At a time, you can break one stick in 1 minute. If I submit you 10 sticks, how much time you require to break all the things? Definitely 10 minutes time is required. Instead of doing that, if I have 10 team members, if I distribute these sticks to 10 team members, if all the 10 people started breaking at a time, what is the time now? Even the 10 sticks, 1 minute. So that is simply called as parallel process. So in the case of parallel process, your data will be processed by, your data is distributed across multiple systems, multi-systems parallelly processing your data. Please come, sir. Sit there. Multi-systems are parallelly processing the data. A small example, the previous processing style is like this. If you have 1 terabyte of data, if I have 1 terabyte of data in our table, this entire 1 terabyte of data will be kept into one single system. If you run a query to process that data, that entire process should be done by that one system. Suppose for that process, if that system, the non-distributed system has taken 10 hours time, just assume 10 hours time it has taken. Now same thing in distributed systems. Your data is distributed into 100 machines. That means 100 systems. Now what is the time to process that? If all systems parallelly processing, data is distributed across 100 machines. Data is divided into small chunks. Each chunk is distributed to separate system. Now your time will be 10 hours divided by 100 minutes. That means 0.1 hour. 0.1 hour means how many minutes? 6 minutes. Same data volume. If the data volume is processed by Oracle 10 hours, same kind of volume processed by Teradata or Vertica or Netezza kind of systems, the time will be 6 minutes. That is the advantage of the parallelism. Nowadays, from not now, from 2005 onwards, where is that picture? 2005 onwards, Teradata, Netija not in 2005. From 2011 onwards, Netija became popular. But before that, Teradata and Vertica was very popular. In those things, the parallelism feature is available so that even though big volume of data, they can process the data very high speed. So all of you online team, the meeting time is going to break up in 10 minutes. That will be breakdown. So please join immediately into the same meeting link, sir. If meeting is terminated, please join with the same link. Immediately I will start it. So that is the benefit. So that's why for the data warehouse purpose, instead of using regular databases, they are using special databases. So Teradata, Netija kind of things are very faster. But there is a problem. These are good up to 200 terabytes. If data volume is greater than 200 terabyte, again, these will start giving slower results. See, no issues later. Suppose 10 years back, these were very good databases. But nowadays, the same thing are bad databases for latest industry. Because data volumes are more than 200 terabyte. Especially all of you people know about this organization. Okay, very familiar, very known application to you. Of course, max to max, it has a history of 10 years, Redbus. But nowadays it is generating more than 20 terabyte per day. It's not per year, sir. It's a volume of per day. Think that for their history maintenance, historical data maintenance, backend is Teradata. How many days of history of Redbus you can keep into Teradata? Of course, for us, Redbus might be big organization. For the industry, Redbus is a small organization. Being a small organization, it is generating 20 terabyte per day. Think that, imagine backend is Teradata. How many days of history it can capture? Teradata is good up to 200. Maximum 10 days of history it can. Just because of 10 days, can you call it as history? No, 10 days comes under recent only, right? Okay, let's talk about Facebook, sir. Facebook in 2013, sir. In 2013 story, Facebook was generating 110 terabyte per day. Imagine backend is again Teradata. Not even 2 days data. You know, nowadays Facebook data volume in 2022 per day 3 petabyte. The Facebook volume per day 3 petabyte. Not per annum, not per a decade, per day. Where to store, how to process. All these are the challenges. That's why 10 years back, there was no designation called data engineer. Now there is a designation called data engineer. That to cloud data engineer. If you talk about, for the data engineering, if you talk about clouds, there are 3 popular heroes are there in the market. Google, GCP, AWS, and Azure. Don't ask me which is good. Everyone is good. Okay, your client is liking Azure. Some other client may like AWS. Some other client may like GCP. Every cloud has their own benefits. But why I like Azure, the fundamental reason, basically cheaper in cost. When compared with AWS, when compared with the GCP, to run my data processing, my monthly billing is very cheaper when compared with that other things. This is my attracting point. Your attracting point might be different. Your client attracting point might be different. Why Azure is good. This is my reason. Okay, but every cloud, remember, every cloud is good. Okay. So in this way, like even I'm not sure about exact data volume of LinkedIn, but I have clarity about the transactional frequency. 3 trillion transaction. 3 trillion transactions per 10 seconds. So this is transactional frequency of the LinkedIn. Per 10 seconds, 3 trillion means per minute how many? 18 trillions. Per hour how many? Per day how many? Based on this, you just imagine how much data volume is being generated for the LinkedIn. That is also crossing more than a petabyte in a day. Just imagine for the Facebook nowadays, latest Facebook backend is teradata. Not even 1 hour data, 1 hour data they can keep. So no need to think about Oracle SQL Server kind of databases. They will be blasted. If you direct the Facebook data to the Oracle kind of databases, you will see white smoke from the servers. They cannot bear it. Understood? That's why nowadays you need for the latest data volumes, because data volumes drastically increased. Daily user involvement is increasing to the online applications. So that's why definitely data volume will be increasing. So to support latest data volumes, you need powerful systems. That is data lake. Data lake is a concept inspired from Hadoop distributed file system. Data lakes are inspired from Hadoop. In Hadoop, there is a special file storage system, special file system, that is HDFS. You can guess the full form. DFS means distributed file system. HDFS means Hadoop distributed file system. In Hadoop distributed file system, the basic behavior of the file is divided into blocks. Blocks are distributed across multiple systems. That means in the case of Hadoop or any to support distributed file system, a cluster is acting as a cluster act as a server. Cluster means, what is a cluster? Generally, server means one single CPU in olden days. Nowadays, every server is a cluster. Cluster means group of network of systems. A group of network of systems is acting as a server. Generally, when you talk something as cluster, each CPU is called as a node. You have two types of nodes. One is master node. Second one is slave, or you can say worker node. Data stored in worker nodes, data processed by worker nodes. Master is assigning tasks to the worker nodes. On that way, one network, a group of network of systems is acting as single server. That is called a cluster. In these clusters, distributed file systems are used. The distributed file systems behavior, file is divided into blocks. Blocks are distributed across multiple systems, means multiple worker nodes or slave nodes. What is the advantage of this DFS file system? Advantage. One thing, sir. Point number one, high volumes of data storage. Second one, supports parallel processing. Because data is not kept in single system, data is distributed across multiple systems. When you run a query or when you run a job, these multi-systems are parallelly processing the data. What is the advantage of parallel process? High speed you are getting. If you talk about HDFS, you have a benefit. That is unlimited data storage.